All right. Hello, everybody. Hey, we are going to do a pivot online lab about respiration right now. So if you are not already in the lab, you need to get there. So you're going to need to open a new tab and you're going to type in Pivot Interactives. And then you're going to log in using your Google login. Is that what it's called? Your Google something or other. So log in. And then it's called KJ's Exploring Respiration Rates Lab. And go ahead and click on that. I'm going to walk you through the lab. You're going to do a little bit of data collection on your own, and then I'm going to show you how to do some graphing. Then we'll stop, and I'll make a second video about how to do the last part of the lab, which involves kind of like FRQs, like sort of essay writing, sort of answering some questions that are sort of more in depth and thinking through what we're doing in the lab. So I'm going to go ahead and walk you through this. Pause at any time. I'm going to go fairly fast for the first half. The first part of this lab is real simple questions. They're basically kind of multiple choice types of questions, independent, dependent variable, that kind of thing. And I don't think you need a whole lot of help with that. But it's the data collection. There's tons of data collection in this lab. So we spread it out over everybody in the class and everybody did a little bit of data collection. You're going to do a little bit and then I'm going to fill in all the rest of the data for you. And then I'm going to show you how to do the graph and then we'll stop the video and we'll make another video tomorrow. All right, so let's go ahead and get started. So it says background. Our goal in this activity is to measure data and collect and calculate the respiration rates of different organisms with different temperature ranges. Because we are testing across different organisms, the mass of each organism should be taken into account, so the respiration rate will be measured per gram. Cell respiration, blah, blah, blah. You all know what cell respiration is. Let's go ahead and jump to part 1, developing a question and procedure. So you might want to do the split screen thing with my video right now. So my video is on the left and your pivot lab is on the right. So it says, in this section, you will come up with a method on how to measure the respiration rate of different organisms. There are 4 organisms. You're going to collect data on the rat. I'm going to give you the data on crickets, mouse, and peas so that you don't have to do that. Let me just show you really quickly the video. So just watch my video for right now. And I want to show you a couple things about the video. So first of all, where's the toolbar? Get my picture out of the way. There we go. I want you to notice that there's this little tool button in the corner, and that's really important during this lab. I clicked on it and it opens up a little stopwatch, and you're going to use the stopwatch to collect your data. That's important, so don't forget to press that. So I'm going to move it right here so it's out of our way. And I'm just going to leave it on the sample that says down at the bottom, it says crickets, temperatures 12 to 15 degrees. I want you to notice a few things. It'll time for us. The temperature is actually 12.6 degrees Celsius. Oxygen gas is 19.53% of the total gas that's in the aquarium. And the carbon dioxide is being measured in parts per million. That's what ppm is. So it's 582. So now I'm going to go ahead and hit play, and we don't need to watch it for a long time, but you can see all these crickets. All these crickets are moving around and they're doing cell respiration. Their mass as a whole has been calculated so that we can calculate their respiration rate per gram. So now I fast forwarded it all the way to the end. And now we look, and we can see the time that passed. It was 23 minutes and 23.37 minutes. And then the temperature now is 13.8 degrees. The oxygen gas is 19%, and the carbon dioxide is now 1,263 parts per million. So this is the experiment. You have the option of changing, which you will be changing, the temperatures and the organisms. You will be collecting data on the rats. All right, so moving on. Explore the interactive above. We already did. What are the variables? What are variables that you can manipulate as you prepare to design an experiment? So in this case, and it says there are 3 that we can manipulate. We can manipulate the type of organism, the temperature of the environment, and how long we measure it for. So I'm going to go ahead and hit submit answer, and you have it done. See how easy this is? Number 3. So hopefully you're split screening and you're answering the questions with me. Number 3, what are the variables that can be measured in this experiment? And we can measure the amount of carbon dioxide and the percent of oxygen. And I'm going to hit submit answer, and yes, and yes. Number 4, one of the values that we want to calculate in this activity is the rate of respiration, and it reminds you of the cell respiration formula. And it says, number 5 says, what molecules from the cell respiration reaction could be used in the experiment to then calculate the rate of cellular respiration? And in this case, we're going to go with O2 and carbon dioxide again. Hit submit answer. Moving on. Number 6, in this activity, to calculate the rate of respiration, we will need to find the change in what we measure divided by the change in time. So it says, what formula could we use to calculate the rate of tickle in my throat. The rate of respiration in this experiment. So we could do the change in oxygen over time, and we can do the change in carbon dioxide over time. So these are the 2 correct answers. I told you this is easy at the beginning. None of it's hard. It's just especially easy right now. Number 7, in this activity, to calculate the rate of respiration, we will need to find the change in what we measured divided by the change in time. In the previous question, you identified the 2 different formulas for calculating rate. What will the units for those rate calculations, what will the units be for those rate calculations if you collect data from the interactive? And in this case, it's parts per million of carbon dioxide per minute, and it's percent of O2 per minute. And hit submit answer. All right, and then this is where you actually need to type a couple things. This interactive contains a lot of data. What are 2 possible questions that you could answer with data that you could collect from this interactive? So one thing you could collect are, what are the respiration rates of different organisms? That could be just a simple question that we can answer. Another variable that you can change in this experiment is temperature. So oh my gosh, type well, KJ. How does temperature affect, it's hard to talk and type. Have you ever noticed that? Affect rates of respiration in different organisms. There, good enough. We'll go with those 2 questions. All right, collecting data. Now, this part I really want you to watch carefully. Right here on your, so in the upper right-hand corner of your screen on your own lab, you should have something that says show split question view. Well, unfortunately, everything's going to get really small for you because you're already on a split screen, but I'm going to go ahead and click show split question view. And now what it did is it puts the video, what you're collecting data from on the left, and the questions and the data table on the right, so you don't have to be scrolling up and down. So listen carefully. I'm on question number, let's go back here. Hold on, I'm going to scroll to where we were. We were on, there we go. So part 2, collecting data. It says, in the videos below, different organisms experience different temperatures. Using the videos and the data table, collect and compare the cellular respiration rates of different organisms, blah, blah, blah. So one thing I want you to remember, I want you to click on the toolbar and to open your timer, your stopwatch. That's what we're looking for, so that you have time set. Down here, the organism that you guys are going to pick is rat. So you're going to collect data on rats. The rat. I'm going to give you all the rest of the data. So listen carefully here. I'll hit load right now, and we're going to do the cold temperature one. I'm not going to play it or anything, but there are 3 data tables that come before the rat data table. So there's crickets, there's mouse, and there's peas. You don't need to fill those data tables in, but watch what I'm going to do. I'm going to scroll down. This first one, do you see the word crickets right here? This first one is for crickets. So I'm going to scroll past. This is the data table for the crickets. I'm scrolling past it. The next one is for the mouse. You see it right there? So I'm going to scroll past the mouse one. The next one is for, did it say peas yet? Peas. There's the peas one. I'm going to scroll past it, and I'm going to go finally to the rat data table. I'm going to scroll down just a little bit. And these are the things that you need to collect. I better get my picture out of the way. Let's scoot me way over there. Okay, so this is the information you need to collect. You need to enter in your initial temperature, and the initial temperature needs to be in decimal form. So it's this temperature right here. So I'll just do it for you. It would be 13.3. That's not for you, but on your own, type in 13.3. And then you need to do your initial carbon dioxide, the change in time. So once you get all the way to the end, and it's totally okay to fast forward, nothing exciting is happening during the video. So just fast forward to the end and tell me what the change in time was. So watch me. No, I don't want to do it for you. Let me pick a different organism so that you're not seeing the answers here. So if I did crickets and I scooch all the way to the end, oops, did I do it right? No, I didn't do it right. Scooch all the way to the end. You can see it's 23.37 minutes. So that's what you're going to add for change in time. And then if we go here, I'm trying to make it scooch, this data table. There we go. Then we need the final carbon dioxide level. And then the computer is going to calculate your change in carbon dioxide and your respiration rate. And it's going to give you these really long decimals. I want you to round off to 2 decimal places. So to the hundredths place for all of these. So collect data on all 3 temperatures. So remember, you have these 3 temperature ranges. So you're going to collect data on all 3 of those. Fill those in. Do that right now and pause my video, get this done, and then come back to me. I'm going to count to 5, and I'm going to just assume that you've gotten that data because you need this data in order for us to move on. Okay, go. Goodbye. Okay, I'm assuming that you are back and that you have collected the data on your rat. So now we're going to scroll down one more data table. It's got the number 7 by it, and it's called the synthesis table. And this is where we share the data. So I've already entered in the data. This data actually came from your classmates. So I want you to fill in this information on your synthesis data table so that you have all the information. I'll read it to you if that'll make it easier. Let's see, how do I do this? It's hard for me to get it to scroll side to side. I'm having no success. I cannot get this data table to scroll. Well, that was annoying. Now I'm back. Okay, so the first column under crickets, I'll read it to you. So we're going down. It should be 0.61, 1.94, and 3.69. Now, what I want you to do is to think about the numbers. That was, you're looking at the respiration rates, how much carbon dioxide there is. And you're also looking at temperature. And so I want you to analyze it. I'll give you just a second to look at it, look at the temperatures, and then look at the respiration rates. What do you notice is the relationship between temperature and respiration? You should say that as temperature increases, so does respiration rate, and it's fairly linear. Okay, so now the next animal that we're going to look at is the mouse. And again, I'm having the problem of scrolling back and forth. This is going to make me mad. But let me read them to you. Mouse is 29.72. Oof, that's a lot more. The second one is 15.88. And the third one is 25.98. Oh my goodness, that's totally different than the cricket. So let's see what we can figure out. So let's look at the data. So first of all, what we notice about the mouse respiration rate is that it is way higher than the crickets. Remember that this is per gram. It's not because the mouse is bigger than all the crickets. This is per gram of body mass. So it's got a way higher respiration rate than the crickets do. And the question is why? Can you figure out what's different that matters here? What's different between a mouse and a cricket? I'll give you 5 seconds to think. What's different between a mouse and a cricket that's causing the respiration rate to be so much different? And the answer is mice are endotherms. Endo means in, therm means heat, so they're producing their own body heat, whereas crickets are ectotherms. They're getting their heat from the environment. So if they need to heat up, they got to go move somewhere that's warm, and if they need to cool down, they have to move somewhere that's cold, kind of like a turtle will sunbathe when it's cold. So that's the main difference. And so mice have to use a lot of cell respiration to generate enough body heat to keep themselves warm. Okay, so that explains why the rates overall are so much higher per gram than they are for the cricket. But then the question is, look, it's not linear. It's super high in the cold, it's lowest in the medium temperature, and then it's quite high in the warm. Why is that? Well, it turns out that the middle temperature is fairly close to body temperature for the mouse. And so that's its, we call it homeostatic temperature. That's the stable, normal temperature where it has to work the least to maintain its body temperature. However, in the cold, in order to maintain its internal body temperature, it has to work really hard. So we see respiration increase in the cold. And we're going to talk a little bit later about why we see respiration really increasing in the warm also. All right, I'm going to pause the video so I can scooch my data table over. So give me just a second. So we should be able to compare them again to the crickets and the mouse. So which one are they more similar to? Take 5 minutes to think, or not 5 minutes, a count of 5 to think, which one are they more similar to? Are they more similar in the data? Is it more similar to crickets or to mice? There's a clock ticking in the background. I can hear it. Okay, so it's more similar to the crickets. And why is it so similar to the crickets? It's a really low rate, and we see that it's linear. As it gets warmer, the rate of respiration increases. Well, the answer is that it's increasing because it's an ectotherm also. It does not need to maintain its own body temperature. So as the environmental temperature increases, its respiration increases. Why does it? And we'll talk about that a little bit later. Why does it increase? And we'll get to that. Okay, and then the last one, you should have already calculated this in your own data table. So now we're entering it into the synthesis table, and that's the rat respiration rate. You've got 4.09, 3.54, and 4.19. Now, there's all kinds of wackinesses that are happening here. First of all, you should notice that the rat has a much lower rate than the mouse does. So the question is why they both are endotherms. Why is the rat's rate so much different? What is the difference between the mousey and the rat that's having an impact here? Give you 5 seconds to think it through. And the answer is the size of the rat. The rat is larger. So that's going to have an impact. The size of the animal has an impact on its respiration rate. So I'll just say a couple things here really quickly. Chickadees in Minnesota, they live here all year round, including through our 20-degree below days. Chickadees are this big. Chickadees have little stick legs that have no fur and no feathers on them. How is it that chickadees can survive through Minnesota weather? And the answer is they have an incredibly high metabolism. They have super high respiration rate. Their heart beats between the averages we saw online, it was like 450 to 550 beats per minute. That's like 8 beats a second. That's a crazy heart rate. And that's how it is able to survive this very cold weather. And so what does that mean the chickadee has to do? The chickadee has to eat a buttload of food. A chickadee, we found this online, we researched it, eats about 30% of its weight every day. We found this online. I didn't come up with this data. Humans eat like 1% to 2% of their weight per day. So that tells you how much a chickadee has to eat in order to maintain that incredibly high metabolism, to maintain that high heat so that they can survive. They're so weak. They need to have a super high metabolism. Okay, last thing that we're going to do today is to make our graph. So let's scroll down here, and there's several things we need to do. In order to get the graph to work, we've got to configure our vertical axes. So right here where it says select data column, you're going to pick the cricket respiration rate. This is on the vertical, we need to do what we're measuring. So what we're measuring are the different respiration rates. So we're going to do cricket respiration rate. And then do you see where it says add columns? Click on add columns and then do every one of the different organisms that we picked. So mouse, add column, peas, add column, and finally rat. Oh, I forgot to say something about the rat. Not only is the rat's respiration rate low, but did you notice that it's not fluctuating quite as much as the mouse did? There's a couple things that have to do with that, but one thing I will mention that students noticed is that the rat in the video falls asleep. It lays down and relaxes for a bit. So its respiration rate is coming down simply because it's relaxing, whereas the mousey apparently is moving around a lot more. So that's having an impact, and it biases our results a little bit. Okay, go ahead and hit done. And now this is unfortunate, but this your labels here, they get cut off. There's not enough room. It says cricket respiration rate, mouse respiration rate, and then you can't see the rest of the respiration rates there. But they're all there. Let's go ahead and configure the horizontal axis. So that's what we're purposely changing. So that's our independent variable in this case. And so the independent variable is the temperature. That's what we're purposely changing. So I'm going to hit done. And now we've got a bunch of dots. It's plotted all the dots. The last thing that we want to do, please let me not screw this up. The last thing that we want to do is click this gear and turn it into a line graph. And then we can see the whole graph. So the green V shape, that's the mouse graph, and it's super high respiration rate. The pink line is also slightly V'd, but not very much. And it's higher than the others. That's the rat respiration rate. What happened to my, oh, I didn't, you guys should have all three of them. My cricket is, got deleted. So it's there. I mean, you should have another line that's there for the crickets, and I'm missing that. I've just got the peas there, but I'm missing my crickets. So you should see that they're very linear. They're quite straight. As the temperature goes up, they go up. All right, I think that's everything for right now. We're going to do part 3 on a separate video. So I'll have that video ready for you tomorrow. Bye, everybody. Have a good night.